Hello everyone, in previous lecture I covered mathematical inductions, all the theoretical aspects. In today's lecture we apply that theorem and solve this problem. So what was mathematical inductions? Long story short, you will be given a Pn. It's a statement about n. To validate that Pn, what you have to do? First you have to put n equals to 1 and check whether this statement is true or not. That we call base steps. After that we have to make an hypothesis. It is that Pn is true for k, any k. Finally, we have to calculate pk plus 1 steps. So that is the story. So now come to these questions. Look, here Pn is not given. I mean, there is Pn, but not in terms of n, unlike other problems. So what you have to do? First, you have to extract Pn from here. Okay, now look, for the Pn, this is the thing. The number of subsets of a set F with n element is 2 to the power n. This is our Pn. Okay, the number of subsets of a set A with n element is 2 to the power n. Okay, so this is our Pn. Pn is more like a mathematical expression, so we can rewrite this expression in the following way also. For set A mod A, that means the number of terms, if n, then all the subsets of A, that means power set of A, is equals to 2 to the power n. So these and these are the same. Whatever comes, we are gonna solve this, okay, because this looks like more mathematical. Okay, now for the solutions, what do you have to do? First, you have to take n equals to 1 and validate that this Pn is true or not. That we call base steps. Okay, for the base steps, take a subset A with n element. Let A be a set with 1 element. Okay, but this suggests, since set with 1 element, we know exactly how many and what are the subsets. Then phi and A are the subsets of A, that we know since it has 1 element. What we can say, that is number of subsets of A are 2. We can see it, and 2 is equals to 2 to the power 1. Hence, P1 is true because it's of the form 2 to the power n. Okay, so this is our base steps. Next, according to the mathematical inductions, we have to make a hypothesis. So let's make an hypothesis. So what's that? We assume that Pk is true. That is our hypothesis. Pk is true. Well, so what does Pk means? We have to first write it. Pk is true, that means, that is, if a set A with k element, then it has 2 to the power k many subsets. Oh, so that is the statement. We assume that pk is true. That means we have assumed these things. Now the next, the final steps, we have to calculate pk plus 1. So what is pk plus 1? Pk plus 1 is says if you have a set with k plus 1 elements, then also this results is true. We have to show that. For that, suppose B is equals to A union A, then mod B is equals to k plus 1. So we got a set who has k plus 1 elements. Now we want to calculate, or we are interested all the subsets of B. Look how the subsets of B looks like. The subsets of B either contains this A or does not contain A. One of the things has to be true. So we make these two cases. Case 1, if a subset of B does not contain A, then since it does not contain A, then it is also subset of A. Therefore, look, all the subsets of B, those who does not contain A, are also subsets of A. Therefore such type of subsets are 2 to the power k many, because A has 2 to the power k many subsets. Okay. Now we move to the case 2. It says if a subsets of B contain A, then these subsets can be constructed. Look, we have to use the subsets of A property. How can we do this? This can be constructed by adding A to each subsets of A. Therefore, again, such type of subsets are to the power k. Therefore, such types of subsets of B are 2 to the power k many. Right? Since it is 2 to the power k many, what we are getting? For in this case 1, there is 2 to the power k many. In case 2, there is 2 to the power k many. That means total we are getting. Therefore, thus total number of subsets of B are 2 to the power k plus 2 to the power k is equals to k plus 1 many. Okay, this is the required condition what we were looking for. So we can say that pk plus 1 is true. Well, so finally with these results, since pk plus 1 is true, therefore according to the mathematical inductions, the final step is Pn, or that is Pn is true for all n belongs to natural number. Hence, we have validated that Pn is true for all natural numbers. I think case 2 needs little bit more explanation. Let me do this for you. Suppose this is A and A has k many elements. Okay, 1, 2, these in this way. Okay, k many. And this is the extra element. Using this, you will get the B. So you, suppose you are here and you are holding this extra element with your hand. Okay, now you are holding these hands and you are asking to A that how many subsets do you have? Then A would reply you back that okay, I have k many elements, so I can, well, from the hypothesis I have 2 to the power k many subsets. Then you say, oh, you have 2 to the power k many subsets. I have one element in my hand and I can put these elements whatever subsets I want. So you can put your element to these subsets, to these subsets, to these subsets, any subsets. Therefore, that subset will become the subsets of B. So how many subsets you will get? It's exactly same with the subsets of A. How many elements? You have 2 to the power k subsets. Subsets of B, therefore from case 2, subsets of B goes to again 2 to the power k many. This is the case, and now we just added in the last part. Case 1 plus case 2 is the total number of subsets for B.